resolve.
Sitten tulee, kun vaunu lähtee pieni alaspäin, niin nämä jarrut, jotka on silloin jarrutusasennossa, niin vähentää sen nopeuden sen 3,25 metriä sekunnissa.
Okay, so then when the cars start rolling freely after they get over the hump, these retarders, the yellow things, brown things, they're going to start braking them when the car gets over 3.25 meters per second. That's when they start braking them and they keep it on that speed.
Sitten kun se vaunu on tuolla alhaalla tuolla raiteella, missä nämä kaksipuolinen jarru kettiin molemmilla puolilla, niin siellä se nopeus laskettiin 1,4 sekunnissa, millä ne saa törmätä toisillaan.
So once they get down to the actual classification track, you still see the same retarders on both sides of the track. And that's where they slow it down to 1.5 which is about 5 kilometers per hour speed. And that's either the cars are going to slow down because of the friction or they're going to hit the other car. And that's the speed they hit the other cars. And they tighten the load so that it has to be able to take that. Crew is at the Tampere railway station getting ready to ride Emma, the Finnish track measurement vehicle, which is just about to pull up to the station right here.
But we use here now on real time, we use from 0 to 40 meters so that we can see all wavelengths on real time. If there really is some defect, we can really immediately call somewhere to tell at the necessary or send people. Because these results, people use them to safety and people they can. Now for example, do you have any idea here what you see here? For example, this is short. That's what you see, track geometry. That's how this track is planned and these curves, upper levels and everything. And we are treating them as a craft and also as a list to the people who are really take care of maintenance. And these people are always with here, who are in charge of this maintenance of these tracks because of safety and because of economy. And they really get these real-time printings of these measuring results and also this wavelength that we use here is the short wavelength of the measuring cord, that means 12 meters astrometry measuring cord, and we reprint these graphs and all this with this cord. And also we can use these longer wavelengths, for example, because of high speed. We can use here. And here you can see there's some wavelength about under 10 meters, and you can do this about 20 meters back.
So there's different tolerances for the turn-ons then?
It's almost tolerance is a different. This gauge, narrow gauge counts. It has to be inside the turn-on. Because we have axle under